So when we prove these triangles congruent, we haven't looked at every single corresponding part, right? Sides and angles, just a few of them are little shortcuts of theorems here. But once we do prove them congruent, what can you then say about all of the other corresponding parts? They're congruent, right? So once you prove the triangle's congruent, we know that all the corresponding parts of the congruent triangles are congruent, right? And we have a little abbreviation for this. You guys see that in your book there? I guess I printed this, I set this up in black and white somewhere, whatever. So if the triangles are congruent, then corresponding parts of congruent triangles are congruent. That's a lot to write, you know, when you're doing a proof, especially for quite a few steps. So we have this abbreviation. What's that abbreviation? CPCTC, okay? Now, if you're going to use this abbreviation, you have to get it exactly right or you don't get credit for it, like it has a reason, right? So let's say instead of them asking us to prove two triangles are congruent, we go down here. And in this first example, what is it they want us to prove here? Segment AC in that diagram is congruent to segment EC. Well, those two segments seem to be parts of what? Two what? What shapes are those? Triangles, right? So if we want to be able to prove that these are congruent, we should first prove what? That prove that they're triangles. Prove that, right, yeah. So prove that they're congruent. So that would be just like yesterday, right? So today is really just one more step. You can see that, okay? So let's take a look at this first example, all right? So we're given that AB is parallel to DE. They've already got it marked. Okay, that's fine. And then BC is congruent to DC, and they've marked that, okay? From what they've given us, is that enough to prove the two triangles congruent? Not quite yet. We're going to use one of these methods, side angle side, etc. Does anybody see anything else we could find that would make them congruent? Or right here. Yeah? We could do vertical lines. So there's a couple of ways to do this, right? We have the parallel lines, don't we? And we know about alternate interior angles and such, right? Okay, the lines are parallel. So look what they said here. They said angle B here is congruent to angle D. Why would those two be congruent? What's that angle pair name if you've got parallel lines? Right. So maybe this helps. If I extend these out, now does it look a little more like the two lines in a transversal like we studied yesterday? Okay. Let me get that so we don't get it all messy. Okay. And they also say that angle A is congruent to angle E. Is that for the same reason? Yes or no? Yeah. If lines parallel. So these two pairs of congruent angles we can write in one statement, so you don't have to, right? But then if they're going to be the same reason, you might as well make one statement out of it and just write that reason one time. Now look very carefully at the reason. Read that. What does it say? If you have to, you can't just write, I see a lot of kids will write for a reason alternate interior angles, and that's it. Does that get it, you think? No. First of all, you got to say that they're congruent, right? It's like vertical angles. But when are alternate interior angles congruent? Only when the lines are parallel, right? Remember the first time I showed you these, I made the lines not parallel deliberately, right? And they were not congruent then. So your reason has to include if lines parallel. See how we abbreviate parallel, by the way? You can do that too. Everybody gets that, right? The symbol for parallel, okay? It was nice to save writing, do math if we can. If lines parallel, alternate interior angles are congruent. Well, now do we have enough to get the triangles congruent? By what? Let's check. So I have my first A. Do we have a pair of angles stated congruent? Uh-huh.
Yeah.
And for the other A, do we have another pair of angles stated congruent?
Yes.
Okay. For the S, is there a pair of sides stated congruent?
Yes.
Right here in the given. Okay. So if you're going to use an A and an S, you need two pairs of angles stated congruent, right? Sometimes kids say, all right, angle congruent to angle, that's two angles, that's both my A's. It's not, right? Each of those A's is a pair of congruent angles, all right? So now we can say the triangles are congruent, right? Well, the triangles are congruent. Can we now say that AC and EC are congruent? Why? CP, CTC. Corresponding parts of congruent triangles are congruent. Now, what's important here is, before you can say that these angles are congruent, alternate interior angles, what needs to be stated first? You have to, it's either going to be in the given, right? Or you find out some other way that the lines are parallel, right? And you have to state it. Because without, this is important, without this statement right here, you cannot make these two here. Everybody get that? Because look at the reason. If what? Well, that means you have to have stated it, right? To make it true. So the condition has to be there in the statement, okay? You've got to have it stated. Now, here's another thing I said. I'll see, like, once we do this, kids will write the triangles congruent, and the reason will be CPCTC. We'll see if anybody does that, right? That's not the reason, right? CPCTC stands for what? What does it mean? Chord of congruent triangles. So if you're going to use congruent triangles as your reason, what do you have to have stated? That the triangles are actually congruent. Well, you can't use that. You get the idea? All right, let's look at the next example. Here's our diagram. We're given that AC congruent to EC. Let's mark that. Okay? And then BC is congruent to DC. Let's mark that. Now let me ask you a question. Can we say right now that angle A is congruent to angle E because alternate interior angles? Can we say that? I saw a couple of ideas. Why can we not say that?
Don't know the lines are parallel.
There's nothing in here about lines being parallel. It's another common mistake. This one looks a little bit like that, right? And you say, well, those lines look to be parallel, so those angles have to be congruent. They can't look to be parallel. It has to be what? Stated. Okay? So we need to find another way to get these triangles congruent, because we want to get angle B congruent to angle D. Anybody see another way to get something else we need for one of our congruence theorems? The what? The vertical angles, right? So what are the angles here? Angle C? Is that what you're going to tell me? Please don't tell me angle C. There we go. Right? So angle BCA is congruent to angle DCE, because vertical angles are what? Some people are still leaving that off there. It's got to be there. Okay? Do we now have enough to get the triangles congruent? By? Let's check. The first S, do we have a pair of sides stated congruent? For the A, do we have a pair of angles stated congruent? And for this other S, another pair of sides stated. You got it? So now we can say that. Now that the triangles are congruent, is angle B congruent to angle D? Reason? Okay, you kind of getting the hang of it here a little bit? So it's a lot like yesterday, except just one more little step, okay? So, I believe on the next page, here's a couple for you guys to try. I'm going to give you a minute. Read it over. Mark your diagram. Now be careful with this first one. In the given they give you there's a segment bisector. You need to make sure you have a statement for that, okay? All right. So take a moment. Everybody like to just share their general plan here about how they're going to approach this? You really want to think about a plan before you start writing. What's your thoughts? Anybody? You scared? You afraid to be wrong? Humiliated? Remember, it's where true learning takes place, right? Doesn't it? I don't know. Is it that you don't have any idea? You just don't want to say anything? Let me walk around and see what you got. Mark what they gave us here. AD by 6. Angle DAB. What does that mean? What does that mean here that AC bisects angle DAB? Anybody tell me? Oh, and what would be the reason for that statement when we make it?
The definition of angle bisector.
Definition of angle bisector, right? I gave it to you. Divides an angle to two congruent angles. But did they state this, though? Here's the thing. Is this what I marked here stated yet? You know what that means, right? You have to make that statement, okay? And they also give us AB congruent to AD, right? Well, who can tell me what they did next? Wait a minute. Are these two angles congruent?
No.
They're not, right? A lot of kids will do that. Why can you not say they're congruent? Well, and that only bisects DAB. It didn't say it bisected the other one. Everybody got that? Okay. So we need another congruency in here because we're trying to get the triangles congruent, right? What's the other congruency?
Second line AC. Reflexive property.
So AC is congruent to itself by the reflexive property. We have enough to get the triangles congruent now? By? Okay, see, I made a plan before I started writing anything, right? I get it marked up, maybe jot some thoughts down or whatever. Okay, so it's side angle side, and then we can get CP for angle B and D. So let's go through this. So one, the given, so we do AC bisects angle BAB, and AB is congruent to AD. The reason, of course, simply given. Okay. Now we've got the given. Let's state things that we found. What was one of the first things that we found?
Angle DAC is congruent to angle BAC.
DAC congruent to angle BAC, right? And we have to use three letters here. At some point, I'll show you a quick shortcut to that. And what's the reason for this statement?
Definition of angle bisector.
Definition of angle bisector. Just abbreviate angle and use a symbol. Okay? Well, we still haven't stated enough to get them congruent. What's another statement we need? AC is congruent to AC, right? Reason? Say that word. Reflexive. A lot of people are writing down reflective, which is not right, okay? It's a different thing. Reflexive. Or abbreviate like this. If you're going to write it out, it has an X in it, not a T, okay? Okay. So now what? Now what are we going to say or state? All right, I'm not going to write the triangles are congruent. What am I going to write actually? Well, what?
Angle B.
Angle B, what?
Congruent to angle B.
Why would angle B be congruent to angle D?
Oh,
Not yet.
yeah.
I need some triangle congruent. What do I write?
Triangle BAC is congruent to triangle BAC.
DAC congruent to triangle B. Let's make sure we got the, because this is important now, right? If we're going to talk about corresponding parts, remember we kind of need this statement correct. That's why we practiced it before. So let's make sure that we go D to A to C. Will that correspond? You said B, A to C? Okay, yeah. B, A to C. Because now look, we need these two congruent. Do they line up in our statement? Okay, good. What was the reason, by the way, for the triangles?
Side angle side.
Side angle side. And now we can state what? B congruent to angle D. Reason?
C to the C.
Corresponding parts congruent. Triangles are congruent. Okay? It's not much more than yesterday. Similar. Okay? You'll see some of the proofs will throw a couple little twists in there that we'll have to adjust for. And maybe I'll have to show you some things as we go. Okay? But all right, let's take a look at number 2. You guys read it over. Get your diagram marked. Make a plan. Okay? They really didn't give us any congruencies in the given, did they? Did they? Not directly, right? So you probably hope, I hope you're thinking you need a statement here. So hopefully you figured out by now, it says C is the midpoint of AE and BD. It's nice, it's not just one of them, right? So what can we mark congruent here, guys? AC to CE, and what else?
BC to CD.
There we go. So we're trying to get those triangles congruent to get the corresponding parts, yeah. Okay, what kind of angle pair is that? All right, now name those angles properly. We can't say angle C, right? What do we have to say? BCA and DCE. There you go. Vertex always goes in the middle. Does that give us what we need for congruent triangles? Okay. And then C for those. So let's get writing. So 1, C is midpoint of AE and BD, AE and BD. And guys, make sure you're using your symbols right above segments, a little segment symbol above it, and angle in front of angles, and triangle symbols in front of what you intend the triangle to be, right? Okay? Don't be sloppy about that. So 1, that's our given. Okay. So they didn't give us any congruency in the given, right? So we have to state some things. Now, the 2 congruencies at segments we have there, right? Will they be for the same reason?
Yes.
Okay, so we can wrap them up into one. You don't have to, you know, but I like to save steps here. So what would be our next statement, would you say?
Segment AC is congruent to segment CE.
AC congruent to CE, and I'll just put a comma. The other one is?
Segment BC is congruent to segment CD.
Congruent to CD. And what's our reason? Definition of midpoint, right? Works a lot like segment bisector, right? But it depends on what they give you. If they said that the 2 segments bisect each other, you'll say definition of segment bisector. If they say it's a midpoint, definition of midpoint, right? Really the same kind of, right? Because a bisector goes through what point? The midpoint, anyway, right? So, okay. Then we found something else. The angles. So it would be angle what? BCA or ACB, right? Congruent to angle DCE. Reason? Vert angles congruent. What will be our next statement?
Triangle ABC is congruent to triangle ABC.
Okay, and let's double check and make, so remember, I got triangle symbol, not, right? I don't just write ABC. You said ABC, BC, congruent to with the triangle symbol. So ABC, what would that be in the other one? So I don't think D. A would go with E. What would B go with? D, right? You see how it goes like that, right? So triangle EDC. So does AB here go with DE here? I think, you know what, I think they probably should have said ED here, right? I think that's an oversight on their part, but not a huge one, right? They're referring to the same segments, right? So we'll have to ignore their sloppiness for a moment, I guess. And what's our reason for this congruency? Side angle, side. Can we get to what we want now?
Yes.
Which is? Congruent. Yeah, you can all say it at once, man. That's great. I love it. DE reason. DC. All right. Here we go. So any questions about how we do that? It's not really totally different than yesterday, right? Just the addition of that extra thing there. Let's take a look at some Regents questions. Only 2 of them. The next page here. Again, there's no Regents proofs that are quite this simple, so we don't have those to look at yet. They'll be fun to get to when we get to them. It'll be a challenge, I think. So let's look at this first one. Read it, and I would definitely mark some whatever they give you in there, or you know, or certain things might be congruent, whatever they give you, right? Mark that. So let's mark what they do give us. And so as we look through all these choices, this will always be in place, and congruent to SC. What else will always be in place here? Whatever they, yeah. There you go. There you go. Vertical angles will be congruent. Okay, so now we can just start like applying these one at a time and see which one. And by the way, does anybody see a condition here? Prove they're congruent specifically by what? Right. So if one of those options down there gets them congruent, but it's side angle side, is that going to answer the question? Right? Okay, so you got to pay attention. What do we think? Maybe you have time to look through them yet. I'll give you a minute. 4. And parallel to SC. Now, when they say lines are parallel, I see this a lot. Does that mean that the lines are congruent as well? No, right? You know, congruent, parallel don't really have anything to do with each other, right? For example, you have to write this down. If I tell you those guys are parallel, clearly they're not congruent, right? So they don't mean the same thing. That's a common mistake I see. So he says that, why do you say that 4 will cause them to be congruent by angle side?
Because it means that angle A is the same as angle C.
A and C?
And
A and C? A and what?
S.
Because what kind of angle pair is that? If the parallel lines are there and that's a transversal. Okay, and they're congruent. What else? Well, and wait a minute now. Does that right there give us angle side? We don't even need the other one, do we? Right? So it is 4. Let me clear that out. I want to just check some of the other conditions though. So everybody sees it's 4. Yeah. Perpendicular. Right angles, right? Let's check that one. If AS is perpendicular, right, that gives us a couple of right triangles. Would that get the triangles congruent by anything? No. Okay. How about K is the midpoint of NC? That would make these congruent. Yeah, would that get them congruent anyway? Because that's what?
Angle side side.
All right, can't do that. Okay. Get rid of that. What about AS and NC bisect each other? Won't that kind of put us in a similar boat? Really? Well, that would be side, right? But they want an angle side, so it's answered 4. Okay, let's move along. You guys notice the wording here. Sequence of rigid motion, mapping things onto mapping. You could replace all that with the word what? Instead of saying they map, those parts map to each other, those parts are congruent because it's rigid motion doing the mapping, right? So they play with the words a little bit, hoping that you know, right? So rigid motion, mapping. So I would mark those in your diagram. We got A, the angle X, and C onto Z, and then AC onto XZ. And what we just talked about kind of needs to know our explanation, right? Is BC congruent to YZ? Would you say?
Yes.
Okay. Why? Let's spitball this a little bit.
CPCTC.
Well, possibly, but you left out one real important part. Now, why are the triangles congruent?
Angle side angle.
Why are the parts congruent that you mentioned?
Because rigid motions make them congruent.
There we go. That, right? That's what we're getting after. So they want you to understand or demonstrate and know that the rigid motion mapping means they're congruent, right? So you might say, after a rigid motion, And they were pretty specific about saying what maps to what, so maybe we'll replace the word mapping in their statement with congruence, right? So they said what? Angle A, or we're interpreting angle A congruent to angle X, right? And what else is congruent?
Angle C, angle D.
Congruent to angle Z and
Segment AC, segment XC.
to XZ, yeah. Okay. Okay, so we know they're congruent. And so what about the triangles? So triangle ABC, what?
Is congruent to triangle XD, XYZ.
Yeah, a little trick, right? Let me show you a trick here to figure out what goes with what. You see the angle congruent marks we put in there, right? You can use that to navigate around. That'll be real helpful later on. We get some kind of confusing diagrams. So we know that A goes with X, so triangle X will be, we'll have to go with Y, right? X, Y, Z. All right, I need one more thing here. By triangles aren't congruent by CBCBC. Angle side angle. Right? So what?
Segment BC is congruent to segment Y.
By,
CBC.
right? There we go. So you need all that, right? That's a question that they are testing to see if you understand the connection between rigid motion, mapping, and congruence, right? They're also testing in this one question whether you know all the congruence schemes for triangles, okay? And also that you know that corresponding parts of congruent triangles are congruent. So they can load a lot into one question, right? And it connects back to stuff we did a long time ago with the rigid motion, right? See how it all gets connected in this class, okay? All right, that was the last one, right? Okay.